Okay, now let's discuss more detail what is convolutional operation. Actually, for those who already take biomedical signal processing as well as biomedical image processing, you should familiar with convolutional operation, because that's why CNN is very close to those who expert in image or signal processing, because as you can see that even if for those who take image processing class, they realize that 50% of the topic is talking about convolutional operation. Okay, it is the same operation that we use in image, but the purpose is different, meaning that in image processing we apply the convolutional for enhance the image. Okay, then you have one filter where actually that filter will be convolve with your image to remove any noise that you want or to enhance your image. For example, you want to make your image more blur, then you are using certain filter to convolve with your image. And then if you want to use to make sure that your image become more sharpened than before, then you can use certain filter to convolve with your image. So the operation is similar to what we have here in artificial intelligence, but the difference is that now the filter, the filter wake or the kernel or the filter element inside that filter become that is actually in AI, that is your W. The filter coefficient is your W, where that W is depend on the training process. So in image processing, we decide the W based on what have been experimented before, meaning that if you want to blur the image, this is the filter coefficient. If you want to sharpen the image, that is the filter coefficient, where you have a averaging, you will have a Gaussian and so on. So that is already fixed with certain filter value. But in convolutional neural network, the W is set according to after the training process, meaning that what is the best W represent that convolutional network is depend on the training process. So we don't know what type of filter coefficient have been provided, and that filter coefficient is actually represent your layer, or you represent your hidden layers in convolutional neural network. Okay, so I think for those who might not familiar with convolutional process, especially those who don't take biomedical image processing, I think especially for the third year student, you need to see I will prepare another video which is explaining the fundamental of signal, as well as how actually one-dimensional signal become two-dimensional in image that represent the image, as well as how actually we execute convolutional from one-dimensional signal into two-dimensional signal. Okay, and in this video, I just skip that part. All I want to I will go directly to this operation. Okay, as you can see here, okay, how actually the convolutional operation works. Okay, this one I take from the image processing books, so it's a little bit it's not properly aligned and suitable to be used here in AI, because for in my opinion, it should be this one is your hidden layer. So the arrangement should look like this. This is your okay, it should be, this is your input image, and then this is your kernel, and this kernel is also known as a filter. Okay, same. Because in the image processing class also we call it as a filter. You can call it as a kernel, you can call it as a window, and so on. So this is your kernel, and each kernel or each filter have their filter coefficient. Actually, filter coefficient again is a W in Convolutional neural network is your W, is your W, and then when you apply a convolution in each every point over there, then you will produce the output image there. So this is the input image, okay, and this is your output image, and this is actually is a filter or one of the hidden layer. Okay, it's a hidden layer. This one is a hidden layer. So when you apply the input with this hidden layer, then this is the output. So that's why we don't draw this one again, like I mentioned in the previous slide. Normally we don't draw the hidden layer like this one. We don't draw the hidden layer, but we draw the output after this process. So that's why normally if you look at this figure, normally we only draw this one and this one, not this one. So that's why because this one is taken from image processing book, so it's not properly arranged, because we in image processing book they don't talk about this kind of representation. So that's why they don't draw the kernel at the center. So but for artificial intelligence class, I think it's better for you to draw the kernel at the center here. So now when you apply this all kernel, you apply to this small input or a few input at a few value at the input layer over here, then you will produce this one. So meaning that there's a 3x3 input. It's a meaning that only a part of the input will go into this process, and then this actually will produce only a single net there. So you just imagine this is your net, but I don't know net number what, because it's too many. So that's why it's very difficult to represent the CNN with the previous architectures. Okay, this one is only represent one net, meaning that if you have another value here, that is another net number what, we cannot explain it because it's too many. Okay, so just imagine this is your net number what. So this is the convolution process. So how to calculate this one, to find this net with this filter, is by using this formula. Okay, as you can see, again, because this one is not tally with the picture, this one is a 2x2, but this one kernel is 3x3. But you just imagine this is 3x3. This is input image, of course, because this is 3x3. This one should be 3x3 as well. But because this picture is 2x2, so if you apply with the input here is this one, kernel here is this one. So to find net number one, I assume this is net number one with this at this position, for example. So to find that one, you must multiply with this one must multiply with this one must multiply this one, and this one multiply with this one. So you get, so have you realized that, let's say I don't use this term, I use the term, this one is W, this one is W1, this one is W2, this one is W3, this one is W4. So to find my net here, I just call it net number one, because I don't know, because too many net there. Just assume this is net number one. So if I replace that one, this one is W number one, this one is W number two, this one is W number 3, this one is W number 4. Let's cancel this one. Okay, I replace it with this one. Okay, so A, B, E, F here is the input, okay, is the input from the input layers. So in other words, to find the net one, still you need to do some sort like summation of your W and your x. Just assume this is x1, x2, x3. I'm sorry, this is x1, x2, x3, x4. This one is x5. This one is x6, and so on. So in order to find the net one here, again they are almost similar with the previous network, because in the previous network, to find the net one, for example, then you need to multiply it with your w1 with your x1, which is this one. Okay, net 1 w1 multiply with x1 plus w2 multiply with x2 plus w3 time what? x5. This one is w4 times x6. So in other words, in convolutional operation, the operation is almost similar. It's not fully similar, it's almost similar, because they are implementing a summation of product between w and x. The difference is thus that now you can see over here, not every w involved, I'm sorry, it's not every input involved in this multiplication. Okay, because you have only 4w, and then you are processing only 4 input. Even you have how many input here? 1, 2, 3, 4. 4 times 3 is 12. You have x1 until x12 over here. So again, if you are processing every input over here with the w that you have, then that is called as a fully connected or metric operation, as we have discussed before. So what is the difference between metric multiplication and convolutional? This is the difference. You can see that this is convolutional. Convolutional, the summation process only cover the inputs. Okay, only cover a certain number of input value, x1, x2, x5, and x6 in this case. Okay, and even the w here is very small to cover whole input over here. That's why in the convolutional process, to find every net 1, net 3, you can see that the process there is it's just focus on how many w you have. Is your w, you have 4w, then you only cover or multiply this w with 4 input signals to find each and every net over here. As you can see, for this net, I call it net number 1. This is the value. How about this one? Let's call this net number 2. Okay, for net number 2, again this one is w1, w2, w3, w4. So net 2 is actually your b is replaced with x2. So w1 x2. Okay, because b is x2 plus w2, your c is your x3. Okay, because your c here is x3, I already named it x3, plus w3, what is your f? F is your x6. Yeah, x6. And then plus w4 with your g here. G is what? It should be x7. Okay, x7. So x7. So again, it's almost similar with the metric multiplication, because the operation is a summation of product between your W and your X, but the range over here have been changed. It's not a fully cover all input X, but it's depend on how many W that you have in your filter or in your hidden layers. So that's how is convolutional works. So I think for those who learns the image processing, then the convolutional process, it's seem to be like this, meaning that if you want to find this value, then you must multiply all this W. I'm sorry, if you want to find this net or these pixels, because now this pixel is net, so if you want to find this net, you multiply with this all this W with that input intensity value inside the image, then you get this one, and then you will slide, you do some sliding. You mean you are translating into another point over here, then you you need to slide this one into this area, and then for you to find this net, you still apply the same W with a new X here, then you get this one. And then if you want to find this net, okay, if you want to find this net, then you translate your kernel into this area, then you multiply the filter coefficient between this new x1, new x over here. So that's how it's work. So that's how this operation can be generated. You are sliding your hidden layer or your filter to the entire image up from the bottom, from the upper corner into upper left corner into right bottom corner. So you can proceed all things, and then you produce the output there. Okay, I think if you don't clear about the operation, let me show a little bit the slide from the image processing slide. So the slide not from the image processing class. So then for those who don't take this image processing class can understand what is convolutional into dimensional. Okay, I just want to show you this. Actually, this slide this is a image processing slide note. Okay, but this is the just to show you the animation how the convolution, the two-dimensional convolutional works in this how actually is work. Okay, so it's the same things. Okay, just assume the S7 here is your net, and this is your all the W here is your filter or is your hidden layer. For example, just assume this is a hidden layer, one of the filter that involve in hidden layer. So again, if this the size is 3 times 3, then you are only process x1, x2, x3, x6, x7. Just replace your R with your x. Okay, x8, x11 and so on. So to find the net, okay, just call it net 7 because this number is 7. Just call it net 7. Then you need to do a sum of product between this one and this one. Then after you finish this one, to get the x net 8, then you need to slice the window like that. Now if you slice the window, you still using the same W, but now you are multiply it or do a sum of product between this W and the new area of X here. You don't use the previous one. Now the x1 is multiplied with R2, so you can see over here. So x1 is multiplied by R2 or x2. This one is multiplied with x3. This one is multiplied with x4 in order to produce the net 8. So you will do that to the entire image, meaning that from this corner, from this right upper corner to the for the left upper corner into the right bottom corner. So means that you are slide that one. So means that you will get x8 and then you slide here and slide here. So in other words, this is how it's work. If you have this big image, let's say this is your filter which represent your hidden layer, then you are sliding from here, from this corner up into this corner. in order for you to produce a two-dimensional set of net, because just imagine this is your S and this is your net. So to find your net, then a matrix of net, then you need to slide the window there, because the window will represent your hidden layer. Okay, so that's how it's work. Okay, in image processing they use the same process but for the different purpose. I just want to relate with this because again I said that's why CNN is very close to those who expert in image processing, as well as signal processing. Okay, so that's how the convolutional works, meaning that convolutional is just if you have the image in two-dimensional like this, if you do convolution operation between this kernel, this kernel and this input image, okay, then what is the meaning by convolutional? When you do a sum of product between this filter and this image, and then you do sliding process there, or translation process from this corner up into this corner in order to produce the output image. So that is convolutional operation. Okay, but if you want to find detail why need to do some translation there, then I hope maybe you can have some self-learning on the convolutional operation, and I try to make one video which is start from the basic, what is the convolutional operation, where is actually this come from, but of course actually you can do some self-learning to in order for you to know the convolutional operation, because for those who learned image processing, I already tell them start from the scratch where is actually the convolutional operation come from, the two-dimensional convolution operation, where actually is come from in signal, one-dimensional signal or two-dimensional signal. So that's why they quite familiar with convolutional operation as compared to those who don't take the image processing class. Okay, okay. So again, why they replacing convolutional? Why they are selecting convolutional in order to make the network, which is originally a deep neural network, because you have many hidden layer, and then that many hidden layer network, originally you are using a matrix multiplication. Why you are replacing it with convolutional operation? So what is the reason behind that? Okay, before we go into this reason, I think this is some of the reason which is quite technically, and I will not go into detail why it is better to use the convolutional as compared to matrix multiplication in developing a deep learning that related to neural network. Okay, just I show you the difference there. If I draw the convolutional operation using the circle architectures, circle pictures that represent the architecture that we have this represent before as that represent the ANN architecture before. Yep, you can see over here, I just draw it. So this is the ANN we learned before. Again, the one that you learned before is ANN. When you increase the hidden layer, it become deep neural network, but still the architectures is similar, is a fully connected. So that's why in order for you to find net 4, for example, this is your net 4, then again the concept is similar. You need to do a sum of product, but because of the fully connected, to find your net 4 you must multiply your W14, this one W14 with your X1, then multiply your W24 with X2. Okay, X1, X2, X3. Okay, this one is X1, X2, X3. So okay, to this one multiply with X1, W24 multiply with X3 plus W34 multiply with x3 to find your net 4. So what happened when you replacing, okay, this is also known as, again, this is also known as fully connected or matrix multiplication, or fully connected. In terms of architecture, is a fully connected. In terms of operation, is called matrix multiplication. So what happen if you are replacing this matrix multiplication with convolution? So if I draw the picture, it seems to be like this, meaning that, okay, in order for you to find net 4, of course net 4 is a sum of product again, but not all sum of product element. You just take a few, depend on how many W you have. Since I'm using my window or my filter size is 2 times 1, okay, you can see that only two item is connected together with x4. So that's why I said my filter is 2 times 1 filter. Then I combine with my input here. So again, you can see that because this one is not two-dimensional signal, is a one-dimensional signal. So that's why now is a convolution of, is a one-dimensional convolution. It's not two-dimensional convolution. So that's why your input is in one-dimensional, which is you have 3 items there, x1, x2, and x3, and then you are convolve. Normally you use this symbol to represent your convolution with your filter here, which is 2 times 1. So if you want to convolve, then you need to slide again. You need to slide this one. Okay, first you need to do the sum of product between this one and this one. Then you are producing one value over here, and then you slide into the bottom into the bottom direction. Then you will do a sum of product between this one and this one. Okay, then you are producing another point. So this is your net 1, this is your net 2. So net 1 and net 2, so same like this one. So you will have net 1 here, this we will have net 2 over here. That doesn't matter is it net or O, okay, because of course because after the convolution, then you need to apply the activation function. Later I will show you, but doesn't matter is it net or is it O, still is a 2 times 1 matrix. Okay, so what the good things about this replacing, what is the difference between matrix multiplication and convolution in terms of architecture? So you can see that to find net 3, net 4, then this one W14 times x1, and then plus W24. Okay, this is your W14, this is one W24, this one is W25, this one is W35. So then to get net 4, this is what you execute, means W14 times x1 plus W24 times x2. To get net 5, W25 times x2, and then W35 times x3. Okay, so what are the good things there is that you can see that the connection is less. So meaning that in terms of number of W involved in producing the output or to producing the net at at this layer is very small. So that's why this is what we have discussed before, why they change it into convolutional, because convolutional process make the W very less, the usage of W is very less, okay, in each and every layers. Okay, again, still this is a deep neural network because you have so many hidden layer. Of course, this is just 2 layer. I just show you the example of 2 layer, but it should be more and more hidden layer over here, and you do the operation have been replaced with convolutional instead of matrix multiplication or fully connected, because if you are still using this architecture, then to translate during the feed forward, to translate the information from here to the next layer, then you need more and more W, which is very highly computational in highly computational complexity, meaning that your computer will need to do a back propagation which is very heavy. Okay, so that's why in order to reduce the training time, they're replacing with this convolutional operation. That is one reason. Another one is because there's, if you are still choosing a fully connected layer, most of the time you see that information is a little bit redundant, because all the information net 4 use all 1 up until 3, net 5 you use all up 1 until 3, so it's not very practical to do that, because instead of heavy in processing, it also provide redundancy in data. So that's why convolutional operation is alternative to that. So by applying the convolutional, one advantage is that you can see now the number of the uses of number of W in each and every layer is very small as compared to this one. And another good thing is that the W there is sharing. As you can see, during the convolutional, this is my W. Let's say I call this one is W, my W1. Sorry, this one is my W1, and this one is my W2. Okay, so you realize that when you apply this one is your W1, this one is your W2. W25 is actually your W1, and W35 is actually your W2, because of the translation process. Okay, means that W1 and W2 here will be also applied at here. So you don't need 4W. Instead of 4W, you only need 2W, and that 2W you will do translation for each and every input around here, means that you do some translation. That is the behavior of convolutional operation. So that's why it also one of the advantage, instead of reducing number of W, it's also called a sharing parameter, meaning that to find net 4, you are using the same parameter W1 and W2 as meaning you are using the same W1 and W2 to find net 5, which is also have been used for net 4. Okay, so that's why I put here W14 is equal to W25, which is my W1, and W24 is equal to W35, which is my W2. So it's a sharing parameter. So that is also you will have some advantage in terms of memory. So of course, now the learning process is quite not so heavy, because you have less parameter, and in this less parameter you are also doing a parameter sharing, means that you only have less and less W for each and every process when you execute the convolutional operation as compared to matrix multiplication. So I think that is also discussed here. I think I don't have to discuss this part. Okay, but what I explained before is related to this one, meaning that you can see here, instead of fully connected, have a very fully connected and complicated connectivity like this, then you will have a very, what we call as a sparse connectivity when you apply a convolutional network. Okay, just assume okay, this is one filter. You can see this is one filter to get this net, and then you are sharing this same parameter to implement this one, another filter. You are translating into that direction, and then you are translating into this direction, then you get net 4. Okay, on. So there's the connectivity itself is a sparse connectivity. It's very small connection, and you are reducing the redundant information to be passed to the next network that you have in your network architecture. Okay, second reason is parameter sharing. I already mentioned to you. Okay, it's because of parameter sharing. As you can see that when you have this filter, when you're translating at this position, you are using the same W, meaning that W over here you have W1, W2, W3. Then when you translate at this direction, this one will become W1, this one become W2, this one become W3. So it's called a sharing parameter. The same value, the same W value. You don't have a different value there. You don't have another W there. It is the same W that you use in finding the net 2 should be similar to with the W that in finding the net 3, net 4 and net 5 and so on. Okay. Okay, reason number 3, I think this one need to, I don't have to discuss this one. This is a little bit complicated for you to at your level. So just sharing you that is the two big reason why they change it. Instead of using matrix multiplication, you are using convolutional operator.